Alright, so the goal for this video is to find the area of different polygons, and my focus is going to be on the high school geometry aspect of these questions. So some of them are a little bit more simple, so I'm not going to go over every single question on here, but yeah, so just to let you know. So on the first one, this is a more simple example for number one because the area formula for a parallelogram is going to be base times height, and we're given both of those answers or both of those numbers in the picture. So really all you're doing to solve for the area, you have a base of 5 and then you have a height of 12.5. So you're going to substitute those answers into the equation. And then once you solve, you should get around 62.5 square feet. The other thing that I want to point out is that the height, the base and the height, are always coming from this 90-degree angle. So think about where that 90-degree angle is and what it is perpendicular with. So for example, the drawing could have looked like this, where the height was outside right here, and it could have said 5 feet on the outside. So just realize that. On number 2, this is very similar to number 1, only it's going to require more work, and this is where you're going to have to use the 30, 60, 90 triangle, special right triangle, or you could even use trig if you didn't recognize that it was a 30, 60, 90 triangle. So what's challenging when you're first looking at this question, we know that for the area formula we want to multiply the base times the height. However, we don't have the height given to us in the picture. We only have the base of 11. So we want to solve for the height. So what we're going to do is we're going to focus on this right triangle right here. So I'm going to redraw the right triangle so that it's a little bit bigger and we can hopefully see it better. So here's the right triangle, and it's a 30, 60, 90 special right triangle. So we're given the side that's opposite from the 30-degree angle. That's very helpful because that's your starting point whenever you're looking at a 30, 60, 90 right triangle. If you know the side opposite from the 30-degree angle is 4, then the relationship with the side opposite from the 60-degree angle would be that same number 4 multiplied by the square root of 3. And that gives us this height right here on the parallelogram. So this is 4 root 3. And let me give myself a little bit more space. And just to continue with the process of looking at this special right triangle, if I were to solve for the hypotenuse, we would multiply 2 times the side opposite from the 30-degree angle. So then this would be 8. And I just wanted to go over that, but that doesn't, that's not necessary for this problem, since we don't need to know the hypotenuse in order to solve for the area. So area is base times height. Again, the base is 11, and our height is 4 times the square root of 3. We can continue to simplify this to get 44 times the square root of 3. And then if you were to substitute that into a calculator, or type that into a calculator, you should get 76.2 square centimeters. Let me go ahead and box my answers. All right, on the next one, I'm not going to go through this question. This is a kite. I'll just go ahead and write the formula that you would use. So you would use the formula for a rhombus, which is 1/2 d sub 1 times d sub 2. So these are talking about the diagonals. So the diagonals are given to you. You're just going to substitute the numbers into the formula. On number 4, and so on number 3, you should have gotten 52 square centimeters. On number 4, this is another one that is pretty basic because for the most part you're given all of the numbers that you need to use the formula. So here for a regular polygon we would use 1/2 a times p, and this lowercase a is referencing the apothem, which is it's the distance from the center of the polygon and then perpendicular to one of the sides, so it's creating that 90-degree angle. So this doesn't, let me try to erase that. I feel like I'm not getting much better with I'm using my iPad here, and my handwriting has not improved very much throughout my videos. All right, now to solve for the variable p, capital P stands for the perimeter. So if we want to solve for the perimeter of this shape, you would multiply the length of the side by all of the sides. So this is an octagon, so you would multiply 10 times 8. And then once you solve this, you should get the total area of 484 square meters. All right. Okay, so on this one, this is the one that I definitely want to go over with you. So we're finding the area of a regular hexagon. This one's going to require more work, so I wanted to definitely go over this example with you guys. So let's look at our formula again for the area of a regular polygon. We have 1/2 a times p, where a is our apothem. And when we're looking at this picture, we're given our apothem. So far, we just need to know the perimeter in order to be able to solve to find the area. So what makes this more difficult is we don't know the length of the side. So we're going to have to use we're going to have to go through a process to solve. So what I want you to consider is a circle which has 360 degrees, right? And if I want to, I'm just going to focus on this triangle. If I were to almost slice this up like a pizza, we would have an angle right here at the top, and that angle would be equal to 360 divided by 6. And we're dividing by 6 because it's a hexagon and there are 6 sides. So that gives us 60 degrees. So for this one triangle, we have the angle at the top of being 60 degrees. So now what I want you to realize here in the picture is we're actually going to focus on this triangle right here. Sorry, didn't realize I was using my highlighter there. Let me erase that. Okay, so we're going to focus on this right triangle. And basically what this triangle is, it's half of the blue one that I just created with the 60 degrees. So let me draw a bigger picture of it. So if it's half, that means that the angle at the top is going to be 30 degrees. because we're cutting the 60 degrees in half. Now the side that I'm given of 11, which is our apothem, is opposite from the 60 degree angle. And if we remember the special right triangle, 30, 60, 90, opposite from the 60 degree angle is going to be x times the square root of 3. So if I want to solve for x, which gives me this side, the side opposite from the 30 degree angle, if I want to solve for x, I'm going to divide by the square root of 3. So that's going to give me some number, and you could plug that in and solve, but I like to just do all that at the end. Now realize that I only found this bottom part, which would be this side right here. I didn't find one complete side to the hexagon. So if I were to find this total length of one side, we would double it. So that's why it's actually 22 divided by the square root of 3. Because when I'm multiplying by 2 to get the length of a full side, you're only multiplying the numerator by 2, since it would be 2 over 1. Now because we have a hexagon and we're solving for the perimeter, we want to multiply that by 6. Alright, so what do we get when we multiply by 6? 2, 1, 12, 13, 132 divided by the square root of 3. So now I have all of the numbers that I need in order to solve this problem. So let's go ahead and work it out. So here I could take half of 132 since that's an even number, so that'll be easier to cut in half. So that would be 366, right? So then we would multiply 11 times 66 and then divide by the square root of 3. So if you were to plug all of that into your calculator, you're going to get the area is about 419.2 square feet. All right, number 6 is a trapezoid. So just realize here again that your height could be given inside of the trapezoid, like this. It could have looked like that. Or in this picture, it's drawn outside. But basically, you're just looking for that perpendicular, that 90-degree angle. So for the trapezoid, you would use the formula of 1/2 of base 1 plus base 2 multiplied by the height. So if you were to plug in those numbers into that formula, you should get about 83.8 square feet. All right, number 7. So number 7 and 8 are very similar, so I'm just going to go over number 7 because you would follow the same process to solve number 8. So it says Jim uses a small card and a large card that are similar in size in his magic show. What is the area of the smaller card? So what we want to do is identify the scale factor that's being used to create this smaller card. So in order to find the scale factor, I'm going to create a ratio of the sides. So because we're finding the area of this smaller card, I'm going to put the 8 in my numerator and the 24 in the denominator. So we just created a ratio. And then if I want to simplify, I could simplify to get 1/3. So now what you would do is you could multiply the area that you know, which is 300 384. You can multiply that by the scale factor twice. So you're actually multiplying this by the scale factor squared. And the reason that we do that is because area is two-dimensional. So whenever you're multiplying to create the new shape, you multiply both the length and the width by the same scale factor. That's why we're going to multiply by 1/3 squared. So really that's 384 times 1/9, and that's the same as 384 divided by 9. So you should get around 42.7 square inches. So that's the process that you would use, and you would use the same process on number 8. So if you were to pause right now and try to do number 8, you should get an area of 126.8 square meters. Okay, on number 9, the only reason, so number 9 and 10, we're looking at composite figures, which is a shape that is composed of different shapes that we're more familiar with. So like on number 9, you may see 2 triangles and 1 square, or you could even see that there's a trapezoid and 1 triangle. On number 10, you could say there's 2 triangles. So that's what a composite shape is. I'm going to go ahead and solve number 9 and then just sort of list the steps that you would go through to solve number 10. So on number 9, I'm going to break it apart into 2 shapes. We have our, I'm going to put EQU for equilateral triangle, which is on the left side. And then in pink, over here, I'll write trapezoid. Actually, I'm just going to write trap, because we don't have enough time for me to completely spell out trapezoid. Just kidding. Okay, so here's my trapezoid. And some of you might have said, well, that's a square with a triangle next to it. If you solve it that way, you'll get the same answer. So for my trapezoid, I'm going to use the formula 1/2 of base 1 plus base 2 times the height. So my 2 bases are 38 and 22, and then I have a height of 22. How do I know that? Because this is a square, and because it gives us this little tick mark, that's showing me that this side over here is the same. So that side, which is our height, because it's creating this perpendicular 90-degree angle, is 22. So when we plug in those numbers, you should get that the trapezoid is, sorry, I didn't completely write this out ahead of time. So what is that? 1, 0, 6, 1, 660 for the trapezoid. Alright, so now let's go ahead and solve for the area of the equilateral triangle. So for the equilateral triangle, realize that the sum of the interior angles of a triangle is going to be 60 degrees. So what makes this particular question difficult is we don't know the height of the triangle. And you cannot assume that it's 22, because it's not. So if I want to create a 90-degree or a right triangle inside so that I can solve for the height, that's going to bisect the angle at the top. So this is going to create the 30, 60, 90 triangle. And because this entire side right here is 22, that means halfway across would be 11. So I'm solving right now to figure out what the height would be. So if I know that my starting point is across from the 30-degree angle, since that's 11, then I know across from the 60-degree angle is going to be 11 multiplied by the square root of 3. Man, that's bad looking. That doesn't even look like a 3. So I guess I could draw it a little bit bigger right here. So this is 11. This is 11 times the square root of 3. And that gives us the height for our triangle. So now that we have the height, we can go ahead and substitute the numbers into the formula for the area of a triangle. So area of a triangle is 1/2 the base times the height. And our base of this entire complete equilateral triangle would be the 22. And the height would be 11 times the square root of 3. So half of 22 is 11. 11 times 11 is 121. So then 121 times the square root of 3 gives us the answer for the area of the equilateral triangle, which is about 209.6. So then if I go ahead and add that to the 660 that I have, you should get about 869.6 square feet. All right, to solve number 10, you're going to look at it as being two triangles. So we have this one triangle that I'm highlighting in yellow that has a base of 16 and a height of 8. And then we have the other triangle at the bottom that I'm highlighting in pink. This one has a base of 18 and a height of 10. So you should get that one of them has an area of 90, another with an area of 64. So total you would get that the area on number 10 is 154 square centimeters. I hope this video was helpful.